So if you can hear me, just type something real quick. And I'm about to start chapter 2, increasing, decreasing, and piecewise functions. Okay, Allison. So if I'm good to go, I'm going to start. So the first thing I want to talk about is increasing, decreasing, and constant functions. So when something is increasing, basically it means that your graph is going up. And if something is decreasing, means that your graph, is going down. And constant, it stays the same from left to right. So here are some definitions on the left side. Increasing is when a graph rises from left to right. And then you have decreasing, graph drops from left to right. And then you have constant, where your graph stays the same from left to right. And if you look here on the left side, the right side of this graph right here, they want us to determine the intervals on which the function is increasing, decreasing, and constant. And you always have to start on the left side of the graph. When you go to your first x, so my first x is at -4. And the graph increasing, it increases from -4 to -3. And it's like I'm crawling, I'm going from one point to the other, and I'm only concerned with my x values. I'm only thinking about my movement from one x to the other. So if I'm at Lil Wayne house and I want to go to Lil Baby house, it's like I'm walking a straight line. So if I'm going to Lil Wayne house and he's at -4, I walk to -3. So my graph is increasing from -4 to -3. So I'm only concerned with the x coordinate, not the y. So this is where my graph is increasing. It went from -4, even though the point is plotted at y. We are not concerned about the y movement, only the x movement from left to right. So it increased from -4 to -3. Now, if I wanted to know decreasing, that's when my graph is going to drop from left to right. So this area, wait 1 second. This area right here, that's my decreasing. So if I look to where I'm at, I'm starting at 2 and I'm falling. And if I'm still walking, it's going to be positive because I'm dealing with the x coordinates, but the y's are falling. So if I'm at 2, I'm at J Lo's house. And I want to go to Vianna house. I walk down the street here, and then I'm at 5. So it decreased from 2 to 5. So remember, I'm only concerned about the x coordinates. So I moved from 2 to 5. Now constant, it stays the same from left to right. So I'm at -3. And then I walk down the street to the store because I need toilet paper because everyone took it for the coronavirus. So I'm here too. Actually, I wrote negative. It should be -3, 2. So my constant point is -3 to 2. So I started here at -3, walked to get some toilet paper because I got the runs, and then now I'm at 2. So that's how you find increasing, decreasing, and constant functions. before I do relative maximum and minimum, because I know you guys are reading that already, I'm going to do another example of increasing and decreasing. So I have this graph right here, and I want to know the point where the graph is increasing, decreasing, and constant. So you remember I always start on the left side of the graph. So if I want to know where something is increasing, it looks like increasing is in this area right here. And it seems like I'm at 3. If I'm at 3 and then I walk, I'm at 5. So I increase from 3 to 5. So it went here, see, it went up here. So I increased from 3 to 5. Now I'm gonna do decreasing, and decreasing seems like there's 2 areas of the graph that decreasing. So it seems like here and over here. Now this arrow is continuous, so it's not a point. So this is your negative infinity, and this is your positive infinity. So if I'm decreasing from here, I'm starting at negative infinity and I go down. So I'm decreasing from negative infinity to -1. So I went from negative infinity to -1. And on the other area where I'm decreasing, I'm at 5. So that's where my x is. And then I go down and it goes extending on to positive infinity. So that's my decreasing. So if you have any questions, just chat something, just write something, and I can see it. And then my constant is in this area right here. So I'm at -1. And then I go and I keep on walking, and then to 3. Would it be why would it be infinity and positive, not -5? That's because let me see, because you're only doing the x movement, but this arrow, since it's not a point, that has to be negative infinity. And then at the bottom right here, it's not a point, it's the arrow that is continuous, so that has to be positive infinity. And we only thinking about whether we only looking at the x coordinates. So negative infinity and it drops to -1, and then 5. You got it. Okay. And then so when you add 5 and then it goes down to positive infinity. Okay, so now I want to look at relative maxima and your minimum. Your relative max is let's see if I have a slide. Your relative maximum and your minimum values. Your relative max is like your highest point on the graph. So this is your highest point. That's your relative max. So if you're standing on the hill yelling, help out of toilet paper, that's your relative maximum. And your relative min, that's your lowest point. Now you out of toilet paper and you down here trying to figure out what to do, you said. So this is your relative minimum. So your highest point on the graph is your relative max. So that's your highest. Your curve is going down, and that's your maximum point. And your relative min is when your curve is going like an upward curve. This is not really curvy, but it will be like a upward kind of ditch where you want to hide your food from everybody because everybody going crazy. So that's your relative minimum. So if I go back to this slide right here and I look here at determine any relative maximum and minimum. So I go to the highest point. C1, what's C1? I'll get back to you, John. So the highest point here, if you look at this graph, this is your highest point. That's your relative max. And the trick about this relative, go back on the graph. Let me see. Well, actually, John, it's actually, you're right, it's two. I need my glasses this morning, thank you. So it's this one and this one. So you have two relative minimum. You have a C1 and a C3. Yeah, so that's why there's two. So you can have, depending on the graph, you can have two relative maximums. We can have two relative minimums or more. On the tests and quizzes, we probably have maybe one relative max and one relative min. We're not gonna go too crazy giving you graphs that you have to find like different ones. So maybe that's why I forgot to mention. So it's one at C1 and C3. Thank you for that. Going back to the other slide. Now the relative max and minimum, that's always your y coordinate. So if they wanted to know if you have a relative max, you would find the highest point. So this is my highest point, that's my relative max. And whatever y is, 4.05 or 4 and 500 is 4.05, and your relative max is 4.05, and it occurs when x is negative 1.09. And that's like their giveaway, because on my math lab, they're going to say, what is your relative max and where does it happen at? And, it's going to say x is. So they give you like, half of the information. So you just have to write in your y. Now I'm going to look at my lowest point. This is my lowest point here. And remember, I'm only concerned with what y is because y is my lowest point. But, the relative maximum, that's where we plot the point at. That's why, we say relative max, what is your highest point? And we plot things at y. So that's why it's the y coordinates. So relative min is negative 2.35. My phone was ringing. And your relative min is negative 2.35, and x at that point is 0.76. So that's how you find your relative maximum and minima. So if we look at this problem, I took this problem from my math lab, and it says determine any relative maxima or minima of the function and the intervals which the function is increasing or decreasing. So they are asking a lot of things in this problem. They want to know the relative max. They want to know your relative min, your Aunt Minnie and your Uncle Max, and they want to know increasing and decreasing. So when I look at this graph, my relative minimum. So you're only going to have, in this graph, you're either going to have a relative minimum or a relative maximum. So if I look, my curve is going down. So this is my highest point. So this is my maximum point. And remember that I plotted at y, so I only need the y coordinate. But like I told you before, my math lab has a kind of written like a basic format. It has x first, so x is, and then you just write 4.5, and has a value of, that looks like 2.25, and it's the relative maximum. So the relative maximum occurs at 4.5 and has a value of 2.25. So this is my highest point. It's going as a downward curve. So I'm up here, and so now we need to know increasing and decreasing. On what interval is the function increasing? So they give you some options here. So A, B, C, D. So remember, I have to move from left to right. So if I'm going, starting on the left side and I'm going up, this is increasing. And this is negative infinity. It's not a point, it's an arrow, so it's continuous. So that's your negative infinity. And this is your positive infinity right there. And I'm increasing from negative infinity, and I go up, and it's the first x because I'm moving, I'm walking down the street. So I move up 4.5. So I increase from negative infinity to 4.5. And so that would be C. Any questions so far? Everybody's quiet. Everybody wrapping up in toilet paper, making mummies. And then decreasing is when the graph drops from left to right. So I always want the x is 4.5. And it goes to positive infinity. So what interval is the function decreasing? That is going to be B. So that's how you find increasing and decreasing. Sometimes they want us to find the domain and range of function. So when I look at this problem, this graph, I want to find the domain and the range. And we know that the domain is all your x coordinates or your x values. And then we know the range is all your y values. the thing about domain and range, you have to start on your left side for your domain, all your X values. So you go to your first X here, and then you just go to your last X, because we don't want to write all the numbers from whatever this number is to the end. So you just want to take the first X of your domain, 5, 6, 7. It looks like 7. I'm gonna go with 7, -7. So my first one is -7. Now I want to use a bracket because you see this is a point is a dark closed circle, so it means that it's included in a graph. So I'm gonna write -7, and then I move on to my last X, which is going to be 5. So my domain, my first X is -7, and my last one is 5. So you want to write it in brackets because the circle is closed. Now my Y, I want to go to the lowest Y first. So that's going to be my first part of my range. So my low is 1, 2, 3. Looks like -3. I'll go with -3. And then my highest, maybe -1, 2, 3, +3. So my high is Y, so I'm here. Then I go up. So my range is going to be -3, 3. Any questions on that one? See, though? So how I got -7? Because the domain is all of your X numbers, all the X's that you used to make this graph. So you want all the X's that you use to make this graph. So we always start on the left side. So the first X that we used, it looks to me, I don't know how it looks to you, it looks like it's -7. If I count 1, 2, 3, 4, 5, 6, 7, so -7. It will look like -7. This is I'm standing -7, so that's my first X. So my first X is -7. And if I go along the graph, these are all the X's I used right here. And I ended at 5. So to make this graph, I use all the numbers from -7 to 5 to make this graph. So do you see that how I got that? Okay. So now with the range is your Y coordinates, all the Y numbers that you use. So we need the lowest first. So we go to the lowest, and I think I said it was like -3. 1, 2, 3 looks like -3. So that's my lowest. So when I was plotting my X's and my Y, my first my first Y was -3. And then I went up, I used all these, and then I ended here, 1, 2, 3 at +3. Okay, so that's domain and range. So now we want to look at piecewise functions. So anybody have any questions on increasing, decreasing? So when you do my math lab, just practice. And if you have any questions, you can send me a picture of the problem, and I would do it and send it back to you. So piecewise functions, just like the word says, piece, is our graph is in pieces. So your graph is in different pieces. And the good thing about it, we only are going to define the pieces. We're not going to graph these different graphs. So, you got lucky. So we have this problem, and we want to, for the function defined as f of x is equal to x plus 1, defined as f of x is equal to 5, and f of x is equal to x squared. We want to find these, given these inputs, we want to find the outputs of this. So it looks a little tricky at first because we have a lot going on. Right here, these are the different pieces of the graph. So these are like your conditions. And based on your conditions, these are the formulas that you are going to use. So these are the different conditions of the graph here, and these are the formulas. So when they say find f of -5, we need to find where does -5 occurs in one of these different conditions. So we look at it. We have 3 of them. We have 3 different conditions here, and we need to find a place where -5 will fit in. So I'll go to each one. So I can say is -5 less than -2. I can say is, looking at the second condition, is -5 greater than or equal to -2, or is -5 less than or equal to 3? And if I look at the last one, is -5 less than, is -5 greater than 3? So it seems like it's the first condition. So it says that -5 is greater than -2. So if -5 is greater than 2, I would use the formula x plus 2. And to find the output, now I just have to replace x with -5. So, we just input -5 because -5 is what my x is. -5 plus 1. So f of -5 is -4. I don't like how that 4 looks, but you can't erase it. When you erase, you have to erase the whole board. So f of -5 is -4. Now, if I look at f of -3, find f of -3, I need to know what constraint that I need to pick. So is -3 greater than, is -3 less than -2? Is -3 greater than or equal to -2? Or is -3 less than or equal to 3 for that condition number 2? Or is -3 greater than 3? So it seems like it's the first one again. So -3 is less than -2. So I am going to use the formula x plus 1. I'm terrible at writing it. And just replace -3 with the x. So I get -3 plus 1, which is -2. Now I have f of 0. So 0 is not less than -2. 0 is not greater than 3. So it's going to be the middle one. So 0 is greater than or equal to -2. And 0 is less than or equal to 3. Now this is tricky because it's just a number. It says 5. So that just means that it's the answer, the output is just 5. Looks like an S, but it's a 5. So f of 0 is equal to 5. And that's all you have to do for that one. F of 3. So f of 3 is not less than -2, but 3 is not less than -2. It's not greater than 3, so it has to be this middle one again, because 3 cannot be greater than 3, but in the middle, x, if you put the 3 for the x, 3 is greater than or equal to -2, or 3 is less than or equal to 3. So since that equal is there, 3 can equal to 3, so it's the middle one again, and your answer would just be, your output is going to be 5. So now we have f of 4. F of 4. And so we go back to all my conditions or my constraints. So 4, is 4 less than -2? No. It's 4 greater than or equal to -2, or less than or equal to 3? No. Is 4 greater than 3? Yes. So the formula that I would use for that one is x squared. Replace x with 4. Always write it in parentheses. It's just a habit, just in case my input is negative and I need to square it. I like to have it in the parentheses. So 4 squared is 16. And now the last one, f of 10. And we went in order. So it's going to be the last one. 10 is greater than 3. So I'm going to use x squared again. Replace the x with the 10. 10 squared is 100. And there you have any questions on piecewise functions and trying to find the input to determine the output? Everybody sleep? Who has the coffee? You always probably have the coffee. You have the water all the time in class, Darian.
When I'm home, I drink orange juice and straight coffee. But when I'm in class, straight water.
Wow. So any questions on increasing, decreasing, maximum, minimum, piecewise functions? See, no, any need to see anything else? I'm going to stop the recording, but I'm still going to be in the classroom.